I'm Andrew Gasson. I am the head of our customer organization here at Code Climate, and I'm going to be sharing some thoughts and takeaways that I've been aggregating over the past several months, but kind of culminated at a conference that Gartner put on in Vegas, and wanted to share some of the takeaways from that and how it ties into thinking about vision and strategy going forward. Cool. So one of the big things that I think is very common, very expected, very known is that technology is evolving very, very quickly. I don't think it's evolving as quickly as expectations of that technology. And this became kind of front and center to me as I've been having more conversations with different people, different leaders across different organizations. While the tech is moving quickly, what's being expected of the tech is moving probably at twice the speed. And in terms of the big three promises that I have seen in the first half of this year, we've got generative AI, the co-pilots of the world, the code whisperers. I'm sure you're all familiar with that space. We've got the no-code, low-code space, and then we've got this concept of software engineering insights, is I think the phrase that Gartner is using to call it. The promises associated with these things are pretty standard. With generative AI, we're going to make things faster, higher quality, and cheaper. That's the promise of tools like Copilot. With the no-code, low-code stuff, we're going to build software faster, cheaper, and make it so anybody can do it. With the SEI platforms, such as Code Climate, we're promising that you'll be able to measure productivity and efficiently so that you can make decisions that'll help you be faster, cheaper, and higher quality. So these are the promises that marketing is making. These are the promises that our executives are hearing coming from these new technology players. The reality is a little bit different. So the big realities behind these things is that if you just adopt the generative AI, you run into a situation where you are building the wrong things faster. If you just adopt a tooling for no-code or low-code development, you're going to find that they're great until you run into a limitation that's just inherent to the specific technology that you're doing. Then you're going to need to come up with some wacky workaround in order to make it work, which makes it less maintainable, and you're ultimately in a more difficult spot than you were if you would have just written it with native code. And then with SEI platforms, and we have certainly seen this with our customers, is that seeing data on the screen, well, it doesn't matter if you don't know what to do with it. And one of the questions, when I first joined Code Climate almost a year ago, I'm almost at my 1 year mark now, one of the things that I heard a lot from some of our customer leadership groups were, well, we see what we look like, but now what do we do with it? So the promise of these technologies, awesome. The realities are things that need to be addressed and considered. And I think a lot of what we're seeing is that the promises are being bought into by one set of stakeholders, but the realities are being recognized by the engineering leaders who are on the hook to actually execute against it. And the tension here, the reason why there continues to be tension, and it's only growing between business stakeholders or non-technical stakeholders and engineering leaders, is that the business, we're now operating in environments where capital is expensive. We want to make sure we're getting everything we can out of every dollar that we're spending. I haven't in the past needed to speak engineering, and I don't really know what the real world challenges that engineering leaders face. Now, there's an asterisk here because not every business stakeholder is unaware of the realities of software development, but a good number of them, in my experience over the past several years, have not had to be worried about the engineering world until fairly recently, as they're trying to, going back to the first bullet point, operate in a world where every penny is being scrutinized. And related to that, we want to get the most out of our technology investments, But how we look at quantifying value, or how we look at ROI or cost benefits, the traditional methods, they don't really fit all the time when we're talking about software engineering. So here's a method that I know how to use if we're getting ROI from a vendor. I'm just going to take that approach and I'm going to try to map it directly to what's going on in the software engineering world. I think we all know that that doesn't work. On the flip side, for our engineering leaders, we are expected to do more with less. There's been no secret that there have been widespread layoffs across the technology industry for the past several years. That has not decreased the scope that we're on the hook to deliver. It has not decreased the outcomes that the business is expecting us to be accountable to. So we are expected, and then you add the new technologies that folks are adopting, we are being expected to do more with less than we had before. We're also being measured in ways that don't really represent the reality of the work. You think about, an uneducated way to view software development is in terms of the number of features you can crank out. Well, that doesn't cover the concept of technical debt or the myriad keep the lights on activities that are necessary in order to keep a business operating. So just measuring some of those top-end vanity metrics that are easy to view doesn't represent the reality of the work. Engineering leaders are also being expected and pressured to solve non-engineering problems from their domain. And we'll talk a little bit about this in the future slides here. But the idea that we can fix something with a coding tool that is inherent to a non-technical decision or process that exists, there's just two different worlds that aren't connecting. That's not something that I can fix as an engineering leader unless we've got buy-in and a firm understanding from the other stakeholders involved. So this tension has always existed. And with the advent of some of the new technologies and promise from the previous slides, the tension is only growing because there's being more promises that's feeding into the expectations on the business leader that is driving up the expectations on the engineering leaders who are now having to do more with less. So I actually had a conversation with one of our customers not too long ago. They're in the midst of a large adoption of GitHub Copilot, which is an awesome tool. But this particular leader, she came to me and she said, finance came to me and said, hey, we bought you this technology 6 months ago, and we're not seeing any improvement. Like, we don't think that we're any better than we were before. What's going on? And I'm sure everybody on this call could look at that statement and come up with 100 different reasons of explanations to a finance or procurement person to say, well, we are improving in these areas, but you don't see it the way that it's actually impacting. Or 6 months isn't enough time to make some of the radical shifts that need to be made in order to adopt it. But this quote is kind of indicative of some of the challenges that we're seeing come up. So what can we do about it? The things that are top of mind for me here, and steps that we've seen work, is first you got to acknowledge that there's a problem with your non-technical stakeholders, with your business peers, with your product peers. We have to have a cross-functional alignment that this rift exists. We have to be able to say out loud, that technology is great, but it's not going to solve all of our problems by itself. We need to be able to be comfortable having those conversations with our peers that their expectations don't line up with reality. And a lot of what we've seen at Code Climate with some of our recent conversations that we've been doing is we're facilitating these conversations between technology leaders and business leaders who had never actually been in the same room before and had never had these types of conversations before. It's hard to make improvements if you're not in the same room, if you don't have regular discussion, and it's hard to make improvements if you can't acknowledge that there's a problem in the first place. The second step here is we actually have to paint a picture of the full scope of the challenge, because for us as engineering leaders, we need to demonstrate that the problem is not the writing of code. The writing of code is rarely the most important problem to solve. Like, we're actually pretty good at that. We've got a lot of solutions for creating code. If we're talking about an end-to-end process evaluation, we have things like, well, what does your approval process look like? How are things getting added to the backlog? What's your value stream look like? Do we have processes in place that are mandated because of a compliance perspective or a security reason that's actually impacting our ability to do what the business is asking us to do? If we can visualize the full scope of the problem and be able to point at this tool or this solution helps us here, but the problem is over here, that allows us to have a much stronger anchor for a conversation. This is not easy to do, by the way, but it is necessary work to give everybody kind of that same view of the problem. There's the old phrase of, like, if somebody's standing at the front of the elephant and in the back of the elephant and describing what they see, well, they're both correct, but they only have part of the picture. And that's one of the realities that we deal with in our interactions between our technology leaders and our business leaders. And the third thing here that I think is important is we're getting pressure as engineering leaders to have healthy engineering organizations, to be high performing, to be productive, to be effective, to be efficient. Those are great words, but they're also kind of fluffy words that don't mean a whole lot. So being able to have a meaningful shared language for discussing what a healthy engineering organization looks like, something that I find to be really helpful. And unfortunately, it's up to us to define that and to bring that Rosetta Stone of discussion to our business stakeholders. And if we can bring that mental model to our business partners, then that can kind of be used as the home base for having those future conversations. And I'm going to describe a little bit what I'm seeing here on the next couple of slides. So this model is not new. We did not invent this, but it's fairly common. But if you have not seen it, breaking down the performance of an engineering organization into 4 key categories makes it very simple to start talking about. There's flow, quality, team or organization health, and then value delivery. From a flow perspective, what we're talking about here is how effective are our processes? How quickly, how frequently does code get pushed to production? What about the ratio of planned work versus unplanned work? All of these things that tie into our people getting into a zone and able to deliver what we said we would deliver unimpeded. The quality quadrant here, pretty straightforward. Are our products buggy? Are they stable? Is our infrastructure up regularly? Do we have strong maintainability? And that's a big one that not a lot of people on the business side think about product maintainability. Everyone on this call knows that if we're being drugged down by technical debt on a mission critical workload and we need to make innovation changes or add new functionality to that, it's a slog. The maintainability that comes from software has a massive impact on our ability to continue to innovate at a positive rate. And if our products aren't super maintainable, then business just sees a underperforming engineering team without understanding the whole picture. From a team health perspective or organizational effectiveness, do we have people with the right skills in the right places? Do we have the right team structures to be effective? There's countless different ways you can organize a product engineering team. I think we have customers that are, if we have 100 customers, there's 100 different team structures that folks are using. And, but for what it is you're trying to achieve, is that allowing you to be as performant as you could be? And for us as leaders, are we actually creating an environment where engineers can thrive and be successful? That's up to us to be able to do that. The fourth quadrant is where a lot of if you think about things on two silos, you've got the business silo and you've got the technology silo. The technology silo typically thinks about the first three blocks, doesn't often have a lot of focus on the value block, where the flip side of it is the business is focused on the value block, doesn't have a ton of insight or even interest so much in the first three blocks. But value is ultimately what it all boils down to, is as an engineering organization, are we having an impact on the bottom line? Are customers getting value out of what we're building? Are they able to solve the problems that we're setting out for them to solve? The work that we're doing, is it actually mapped to what the business needs? Do they understand what the business needs, or are we just building features? That value piece is kind of the tie that binds and is what allows us to bring the business and engineering perspectives and unite them as it relates to the rest of this. And there's an example that I've got that I want to get to, and I think it's on the next slide. But the interrelationship between flow, quality, team, and value is something that has to be identified. And if you use this as kind of the framework for your conversation with your business stakeholders and explaining where and why certain things are helping in ways that are expected, but they're not solving these other problems, and here's why. This is like a really easy visual that you can use to overlay some of the adoption challenges or problem challenges that you've got. An example, this is something that we're actually running into in a few of our customers. We have adopted a GenAI tool for faster code writing, which means we are now writing code faster. However, code is not reaching production faster because we're limited to 4 deployments per year. So we're writing a lot more code, but we're still only delivering it 4 times a year, which means we're only delivering value 4 times a year. And that's because of a process constraint that's been established cross-functionally with business leaders. The GenAI tool, therefore, it's not accelerating value delivery unless we make a process change. But the process change or the process limits on deployments were put in place because the business stakeholders wanted to have control over managing the impact to the downstream customers. So the agreement was we will do 4 changes a year. So then when you circle it all the way back, we bought this tool to help us deliver value faster. Well, we didn't actually improve anything as it relates to flow and value because we didn't have alignment ahead of time of what the problem was we were trying to solve. And this is a very simple example, but we're seeing it over and over and over again, where you're optimizing for a piece of the process, but not solving the actual problem that would allow that optimization to make a big deal. This is just one example. This is a real world example that we're seeing in multiple places. But as you're thinking about the vision for your technology organization going forward, you're not going to be able to execute against those expectations that are being set against you if you're not able to tie the whole thing together across those 4 categories. So something to leave you all with to think through as a tangible example. There were a handful of, I'm going to pause here for a second because there were a handful of questions that got submitted ahead of time that we're going to transition into answering. So the first question that came up was, again, very common question, was how can we better showcase to the business the time that we need to do the keep the lights on activities for the system. And this is part of the reason why I advocate for having that shared framework of what performance looks like, is if you're able to demonstrate that, we're spending for every hour we're spending on keep the lights on activities that's allowing this other group to go faster, or the keep the lights on activities is allowing this revenue to keep steady at where it is. Being able to tie together the work you're doing with the impact of the work across the different metric categories is something that I strongly advocate for doing. But again, that only works if you've got a shared understanding with the business of what those different levers are. So having the 4 quadrants and being able to say that activity in this area is what's allowing us to keep doing this over here. Or if we were to make an investment into tech debt, that's going to allow us to move faster, because currently, it takes us 8 hours to do something in this system where it would normally only take us 2 anywhere else. If we could invest 4 hours to clean up some of this technical debt, we're still saving net time. Being able to explain some of those things is almost step 3, where step 1 is, do you acknowledge what the problem is? Step 2 is, can you effectively communicate it in a way that drives shared understanding of the problem? And then step 3 is, can you explain what solving it looks like and what that buys you as it relates to the shared understanding? The second question that came in, do we have any data about whether or not generative AI is helping with developer productivity? Yes and no. So developer productivity, big bucket. At this point in my career, it almost feels like that's not a thing. I don't want to talk about developer productivity because what is that? But is GenAI helping? Yes, GenAI is definitely helping organizations write code faster. We have a lot of data points that prove that. We're also seeing that adopting generative AI without some guardrails in place is increasing the defect rate, and it's increasing the amount of rework that needs to go on. The most successful customers we have adopting generative AI are doing so in kind of a controlled and experimental manner, so that they're able to make sure that they're seeing the improvements that they're looking for while controlling the potential negative impacts that it may have from that increased speed or increased reliance on a tool. So yes, we've got data that shows that if you're using it in a controlled and intelligent manner, you're going to get benefits to your development process. And I see Tony in the chat, interesting that it's causing rework. I think a lot of this comes from if the expectation is, I'm an engineer and I'm just going to accept the suggestions, accept, submit for a pull request. That's what's triggering a lot of the rework. So when you're over optimizing for increasing the velocity, let's just accept everything the system says. Well, when it gets to the code review time and gets kicked back, that's what's driving a lot of the rework change there. And then the third question that came in is, based off some of the stuff that I've seen, what are the big hurdles that companies are not thinking about that they should be? And I think the biggest thing that I've seen and was talked about a lot at the Gartner conference actually was the evolution of leveraging software to do things that humans would do. There's a lot of products that are promising to be able to do the same types of things that you'd normally hire people for. I think what you're going to find is that companies are going to look to replace their employees that depart, or rather than hire an employee, they're going to hire a technology to do something instead. I think what they're going to find is that they still need the people. The most interesting tools that I saw on the show floor were those who augmented the human capabilities, not sought to replace them. There's a product called Warp that I think is really cool if you've not had a chance to look at it. It allows you to essentially talk to your infrastructure in plain English. And I think that's an example of giving your humans superpowers rather than trying to replace them by machines that are going to be right 50% of the time. For most of us on this call, 50% of the time isn't good enough for us to keep our jobs. It's not going to be good enough for the computer doing the job in the future either. So as companies are thinking about making big investments into these technologies, I think the unspoken thing to consider is going to be what is the role that we're expecting these things to play in the real world. And I'm not seeing a lot of that, as much of that as I would like. And that was kind of evident in some of the presentations that we saw from customers that were saying, hey, we tried this thing and it didn't work. Well, it didn't work because you laid off 40 people so that you could buy this tool to do the work of 40 people, and then you found out it doesn't. Making those types of big swing decisions are things that I certainly wouldn't advocate for. The data doesn't support, and something that I think a lot of organizations are going to be deciding to do, and they should really think otherwise on. So we are at time. It was really good to have the opportunity to share some of this with y'all today, and I hope you enjoy the rest of your week.